Welcome to qnawire.
Okay, so when the Sneezy is at the pole, it's just at the Earth's self-orienting axis. So the distance from it to the axis is 0. But when the Earth is at the equator, it has some radius, which is the radius of the Earth to the rotating axis. This gives it an radiational acceleration. So if we draw a 3x diagram, we have the Sneezy here with mass m. So it has a tension hanging it going up, and the weight of it, the gravitational force W, goes up. Okay. So we can find the mass of the Sneezy by using the weight of it at the pole divided by the gravitational constant at the pole. So we have 40.311 kilograms. And the net force is going to be the weight W minus T, right? Because you have a radiational acceleration going down, so W should be slightly larger than your tension, right? So it's mass times, and this net force is equal to, according to Newton's second law, mass times radiational acceleration is equal to m v squared over r, right? So v is equal to circumference divided by the period, because it's on the equator. So it should be the circumference of the equator divided by how long of the one object need to move on the equator for one period, which is 1 day in our case, right? So this r is radius of the Earth. We have this net force, this m, a radius rate is equal to 4 pi square mr divided by tension divided by the period square. So m is just a mass. The rest part is the a radius. So a, we can find that the radiational acceleration is equal to 0.0337 meter per second squared. Now we use this equation. So the tension is just simply the weight minus the net force, right? So the weight is mg. The net force is m times a radius. And we'll plug in the number, right? We know the mass here. We know the gravitational force acceleration. We know the radiational acceleration. We can get the final answer. I think this number is not correct. It should be mass times g minus a radius is equal to 40.311 kilograms times g is 9.8 minus 0.0337, and you may use your calculator to find what the final answer is. Okay.